Welcome back to NPA Teaching. In this video, we are going to discuss how to find the sum of n terms in a geometric progression. Suppose that we want to find the sum of first n terms of a geometric progression. What we get is a plus, ar square plus, ar cube plus up to ar raised to the power n minus 1. If the starting value of the series is a and the common ratio is r is given, then the sum of first n terms in a geometric progression can be found by using the formula. Suppose now we want to find the sum of the first n terms of a geometric progression. Then if the starting value of the series is a and the common ratio is r, then the sum of first n term is Sn is equal to, that is sum of n term is equal to a into 1 minus r raised to the power n divided by 1 minus r. Here Sn is the sum of n terms, a is the first term, r is the common ratio, and n is the nth term of a geometric progression. Now consider the following example, that is find the sum of first 4 terms in the series. So series is given here, that is 10, 30, 90, 270 onwards. So here the first term is a is equal to 10 and the common ratio is the the ratio of 2 consecutive terms, that is 30 divided by 10 is equal to 3. Then the nth term, that is first 4 terms, so n is equal to 4. Then the formula for finding the sum of nth term in the geometric progression is equal to a into 1 minus r raised to the power n divided by 1 minus r. So here a is equal to 10 into 1 minus r is equal to 3 and n is equal to 4. So it is 3 raised to the power 4 divided by 1 minus r, which is equal to 1 minus 3, which is equal to 10 into 1 minus 3 raised to the 4 is equal to 81. So 1 minus 81 divided by 1 minus 3, which is equal to 10 into 1 minus 81, which is equal to minus 80 divided by 1 minus 3. Then 10 into minus 80 is equal to minus 800 divided by 1 minus 3 is equal to minus 2. So minus 800 divided by minus 2 is equal to 400. So the sum of first 4 terms in the series is equal to 400. Consider the another example, that is how many terms of the geometric progression, that is 64 plus 32 plus 16 and up to has a sum of 127 into 1 by 2. So here the question is, how many numbers are there to get the sum of 127 into 1 by 2 in the given geometric progression, that is 64, 32, 16, etc. So here the first term is given, that is a is equal to 64 and common ratio r is equal to 32 divided by 64, which is equal to 1 by 2, and at the same time the sum of n terms are also given here, that is 127 into 1 by 2, which we can rewrite, which is equal to 255 divided by 2. Now the formula for finding the sum of n terms are Sn is equal to a into 1 minus r raised to the power n divided by 1 minus r. So substituting the given values, that is Sn is equal to 255 divided by 2, which is equal to the first term a, which is equal to 64 into 1 minus r is equal to 1 by 2 raised to the power n is not given, divided by 1 minus 1 by 2. So this equation can be rewrite in this form. Now shifting 64 and 1 by 1 minus 2 to the right hand side of the equation, we will get 255 divided by 2 into 1 by 2 into 1 by 64. So 1 minus 1 by 2 raised to the power n is equal to 255 divided by 256. Then shifting 1 to the right hand side of the equation, then it will become 1 by 2 raised to the power n is equal to 1 minus 255 divided by 256, which can be write 1 by 2 raised to the power n is equal to 1 by 256. Then now equating the indices, since they both have the same base, so 1 by 2 raised to the power n is equal to 1 by 2 raised to the power 8. Therefore n is equal to 8. Thus, the required number of term is 8. I hope you are clear about the how to find the sum of n terms in a geometric progression. Practice more exercise and examples so that it can be cleared more easily and quickly. Have a nice day and see you in the next video. Thank you.